Okay, so next presentation is Dr. Phoebe Gordon. She will talk about how will a changing climate affect orchard crops. What I discussed about was broader changes, and then now we'll drill down into more specific to orchard crops. Thanks, Phoebe.
Okay, good morning, everyone. So thanks for the introduction. So I guess I'm gonna. I use changing climate, but mostly I'm going to be talking about temperature and how that can change chill. And I'll also use a case study about warmer temperatures during bloom periods in prunes. So just kind of like a brief overview about why we care about temperatures in general. There are temperature ranges that plants are basically evolved to deal with. Plants like to have, kind of ideal temperatures just like we do. I think most plants would be happy to, be growing at 70 to 80 degree weather and not too much sunlight. But basically, obviously that doesn't happen. We have plants that are growing in the desert. We also have plants growing in cold climates where it freezes and where, tender plant tissues that will photosynthesize will die. If they freeze. And so plants will actually have evolved mechanisms for dealing with this. Heat shock proteins can help proteins stay in shape during hot climates and hot temperatures. And plants can manipulate their internal processors to withstand freezing temperatures as well. But these do have some costs. So there's a particular type of photosynthesis that plants that grow in hot and dry climates use called CAM photosynthesis. And so it allows them to photosynthesize efficiently in lower water environments, but they do have a slow growth as the byproduct, so cacti, for instance. For plants that grow in cold climates that freeze, seeds, and overwintering is a seed form, so annual plants, that is one way to get around cold temperatures. But another way that we're very familiar with in the orchard world is losing your leaves during the wintertime, winter deciduousness. So they're losing these leaves that can freeze, and they're basically, they're woody structures. They'll go through a bunch of processes to be able to withstand freezing temperatures. So we call this dormancy. And there is an official definition for dormancy beyond whether or not a tree that normally loses its leaves, loses its leaves. So there are, the official definition of what dormancy is whether or not a plant will grow if it's in favorable conditions. And so plants won't grow if they're dormant. So there are actually two phases of dormancy within this. There's what's called endodormancy, which is where conditions within a plant will prevent it from growing. And then there is ecodormancy, which is when conditions outside of a plant will prevent it from growing. So you can kind of think about, what happens if you take a plant that's dormant and you put it in favorable conditions. So if you do something like take a dormant plant and let's say a tree, let's say we have a growth chamber where we can manipulate temperatures that's big enough to fit this tree. And so you put a tree that's in ecodormancy in this growth chamber. If it doesn't grow or it doesn't grow regularly, it was an endodormancy. If it was an ecodormancy, outside temperatures are preventing it from growing, and so after a little bit of time, it will start growing normally. How we try to quantify this is different, depending on if a plant is an endo or ecodormancy. If it's an endodormancy, we talk about chill and chill accumulation. If it's an ecodormancy, we talk about heat unit accumulation. So trees aren't sitting in the orchards with a thermometer and a calculator, trying to calculate how much chill they're accumulating. This is what we have done to try to describe what plants are growing and how long they need to stay in colder climates or colder conditions before they leaf out and bloom normally. So the way we used to calculate chill here, and the way a lot of people do still calculate chill, is what we call chill hours, which are basically the number of hours a plant will spend between 32 and 45 degrees Fahrenheit. And so this was developed in areas where it gets cold and it stays cold. But we don't have that here in California. Our winters can actually be fairly warm, especially if you're considering thinking about the Midwest or back east. They don't tend to get 65-degree days in the middle of January. And so there have also been times when we've thought that, plants that require a high amount of chill have gotten enough chill, but then they behave as if they haven't. And so what we think is that the old chill model isn't really appropriate for California conditions because it does get warm during the wintertime. And it's also quite sunny here. And so if you have ambient temperatures that are kind of close to the upper border for when you can get chill accumulation and plant tissues warm up, they can actually not be accumulating chill even though a thermometer that you've put in the orchard will say that temperatures are cold enough for that to happen. Another factor is that we used to get a lot of tule fog. We still get it quite often, but not as much as we used to. And so we think that the tule fog was probably also reducing sunlight reaching plant tissues. But this is just us trying to figure out what's been going on. So there have been other models developed for chill. What we are talking about more is the dynamic model. So if you've ever heard chill portions, that's using the dynamic model. And what it basically does is it takes into account warm temperatures, and it also does weighted temperatures based off of if you're closer to freezing or a little bit further away from freezing. So the big thing to understand about the dynamic model is that the tree will basically start the day and it'll start accumulating chill as long as temperatures stay favorable. But if it gets too warm and it hasn't finished accumulating a chill portion, it loses that chill portion for the day. And then it starts off again the next day. But if it stays cool enough, it will basically complete that chill portion. You can do it in half or full chill portions, and it's in the bank. And so it's not going to lose that. So it will take into account these warmer temperatures that we get and possibly sunlight hitting trees and warming up plant tissues as well. Oh, there we go. This, I will say, work done by Craig Collison, at least for pistachios, has also indicated that chill accumulation may not be the only thing that we should worry about. Back in, I think, 2017, it's been a while now, Craig Collison modeled pistachio yield against several other factors to try to create a yield model to basically say, to try to predict yield. We know that pistachios are alternate bearing, and so if they bear heavily in one year, they're going to have a lighter yield the following year. So when he put all these factors into his model, he found that yes, last year's yield is the strongest predictor of current season's yield because, again, they're alternate bearing. But he also found that rather than winter chill, it was warm temperatures during the wintertime that were actually a stronger predictor of yield the following season. And in fact, they were a negative predictor. So what he's suggesting is we even think less about chill accumulation, we think more about heat during the wintertime. He'll be the first to say, don't take models literally. If you go and look up his model and use his equation, it's probably not going to be exactly right, but it's still a useful tool for us to think about how these temperatures might be affecting high chill requiring crops. So we do have rest-breaking agents available. I'm not really going to talk a lot about them because, I'm not a big expert on them, but also, in my opinion, they're a Band-Aid. They can help out in borderline years. They can also help with bloom uniformity, but they can't help us overcome, or trees overcome, insufficient chill. Some, like Dormix, are, they're kind of nasty chemicals. And so if you're thinking about planting, a pistachio or walnut orchard today in an area that is, starting to lose chill and is predicted to lose a lot in the future, rest-breaking agents aren't really going to help you out 40 years down the line from what we understand. They could probably help a pistachio orchard that's in the ground currently and it's dealing with some issues in some years, but we need to be thinking about other options for the future. There are other things to worry about other than just dormancy. So I'm going to use improved French for an example because it's kind of a bloom. It requires very specific temperatures during bloom. So if you're not familiar with the California prune industry, it's basically dominated by one cultivar, and that's improved French. And in the past, advisors and others in the industry have started to notice that there have been some crop failures during years where there are high temperatures during bloom. We know that pollen tube growth in prune is very sensitive. Basically, so when you have pollen that lands on the stigma, which is the female part, it takes time for it to actually grow down and reach the ovule. It can take, in almonds, it can take a week or two. I don't know off the top of my head what prunes require, but it's a surprisingly long time. And so pollen tube growth will slow down at temperatures below 71 degrees. They'll also slow down at temperatures above 71 degrees. So it's a really narrow temperature range. And if pollen tube growth is too slow, it's a problem because the ovule is only receptive for a certain period of time. So if you have less than ideal temperatures during bloom, there's a risk of crop failure. So this research was led by Franz Niederholzer. I monitored an orchard for a couple of years towards the end, but I just want to stress that he's the one who's in charge of this project. And he monitored between 1 and 7 orchards between 2005 and 2020, so quite a long time. What we did is we collected temperature during bloom and after. We went through and picked out branches in the orchard, counted flower progression, and basically, figured out when full bloom was, and we went back later and calculated fruit set. And so Franz threw all this stuff into modeling, and what he found was that in order to have a crop failure, you need to have early prune bloom as a prerequisite. If that happens, and you either get sustained cold temperatures or hot temperatures at full bloom or just a couple of days after, that was a higher predictor for crop failure. So we know that the prediction for heat waves, because I would say in March, 77 to 81 degrees Fahrenheit is a heat wave. We know that this is more likely with climate change, and so this could potentially be a risk in the future. So not every year that you have this, you're not necessarily looking at a crop failure, but if these things are coupled, there's a higher chance of that. It's not all bad news. Some weather risks are going to be reduced, like frosts. So walnuts and juvenile pistachios are vulnerable to early frost events. We think that what happens is if they're not pushed into dormancy early enough into the fall, freezing or close to freezing temperatures can damage these tissues. And so, we can try to force them into dormancy, but in pistachios, saline soil has been connected to winter juvenile pistachio dieback, which is the long term that's been coined to refer to chill damage. And you can't always, you can't control that. But we think that these early frost events are going to decrease under climate change. And so, frost risk might be reduced in the future. So there are other things you, of course, have to worry about, abnormally dry or wet years. I will say I started working for Cooperative Extension in 2017, and we basically swung between really wet or really dry every single year I've been here, and we know that that's going to continue. Agricultural land can increase in salinity. So with the higher average temperatures during the summertime, that increases water demands for the crop. You're going to have to irrigate more to meet that. And anytime you add irrigation water to soil, you're adding salts, even if you're adding really high quality canal water. And so over time, as we're tightening up our irrigation efficiencies, which is a good thing, we want to do that, but it's going to reduce in-season leaching. And so you're going to have to think about implementing a leaching plan during the wintertime if you don't normally think about that sort of thing. I also say I don't think that we have a really great idea of how extreme heat affects our orchard crops. A lot of the research that's been done, well, in order to do that really well, you have to have a growth chamber, and you can't stick a full-grown tree in a growth chamber, and so you can do a lot of observational work, but we're kind of learning, I think, along with everybody else, how our tree crops are dealing with these heat waves like we had in September. So just conclude so that I have some time for questions. Climate change is going to change temperature and weather-related risks. Some things are probably going to get better, some things are probably going to get worse. So when we're thinking about species that are grown at the edge of their temperature or chill tolerances, that we might have to be shifting them northward where we're going to be thinking about where we're planting future orchards. I think there is some space for cultivars that maybe require less chill. We haven't formally quantified this, but we think that Golden Hills and Lost Hills, for example, have a lower chill requirement than Kerman pistachios based on the fact that they bloom earlier. So we think that they complete their chill requirement earlier. Like I mentioned, I think that rust-breaking agents are kind of a Band-Aid, and they're fine for existing orchards, but if you're thinking about the future, I wouldn't rely on these as a tool to get around low chill years. And so when you're thinking about future plans, you need to build appropriate risk factors into your future orchard and think about, how often can you deal with a low chill year resulting in really poor yields. If it doesn't work out, maybe you should be thinking about planting a tree species that is has a lower chill requirement. Orchard production isn't going away, but we are going to have to think about what the future orchard is going to look like, what the future risks are. And something else I'd like to mention too is that with the drought, I visited a couple of almond orchards where folks planted almonds with wells that were too salty, and they're relying on surface water. And then when the drought happened and they didn't get any surface water, they started irrigating these trees with water that they shouldn't be irrigating almonds with. So it's not just climate or temperatures. There are other things that you should be thinking about. We're going to have more years of drought ahead of us, and so think about other things as well when you're thinking about planting your future orchard. What are you going to be irrigating these trees with when you don't have surface water available? Okay, so I can take any questions.
Hi, I'll make them quick. So when it comes to chill hours, is there any work that's been done on looking on cover on the ground if it impacts the temperatures within the orchard enough to make small differences?
I think Greet Brar at Fresno State is interested in looking at that. I know I've talked to him about it. I don't know if he's been funded, but he's interested in looking at it.
Okay, and then you addressed if we can breed our way out of this problem. Maybe, maybe not. The pollen tube thing, has that actually been looked at in almonds at all, or just in prunes? But they're closely related.
They are, yeah. I could ask Tom Gradziel if you give me your contact info. He would be the person I would reach out to for that.
And last question, on forcing dormancy, back in my dad's day, they used to spray zinc on the trees in the fall to burn off the leaves. Does that help force any dormancy at all? I
don't think that question has been fully answered. I will say I have been told to me by an apple researcher that they've looked at that in apples in South Africa, I think, and they found that if the trees were dormant, so I think apples can kind of do the same thing that young almonds here can, where they can retain their leaves into December or January, but the trees are dormant. So if the trees were actually dormant, it didn't do anything, and if they weren't, it was actually detrimental.
Okay.
But that's just one crop that I've heard of.
Thank you. Well, we need to move on to the next one. Thanks, Phoebe.